The final block I have today is a practical application of a few things we've gone through already, but I'm a graphics person at heart, and this is an actual example, slightly simplified, of a case I had to deal with as a driver developer. So, we have your phones. They have a screen rotation feature. And there's essentially 4 states to orient a phone display. You got the portrait, you got the upside down, landscape left, and landscape right orientations. From your phone's perspective, however, this is just an illusion. It's just rendering the same content in various alternating ways. To achieve this, we need a transformation. Now, I'm not going to go through the concept of transformations here, that's a bit too complex, but I'm going to show you a case scenario I had. I basically want a function where we take in a screen resolution, say 1920 by 1080, which is a typical resolution in a phone, and an orientation in the form of landscape right, landscape left, and so on. I want this function to output the position of this red dot as well as the transformed dimensions. Now, as you probably are aware, strings are not the greatest way of communicating metadata. You can do it by all means, but in low-level programming, we probably want to use an enum. It's the simple way of expressing a 4-state value, and we can just do that. You can see the enum on your right on the screen here. The problem with enums is that they natively give you code duplication. It's just the way they work, and for this reason I personally find enums to be annoying. So here's the function in question, and you can see that it's accepting a orientation, a width and a height, and it returns a bunch of stuff in a structure. You may probably stumble across this and ask why. Why is this not a return parameter? And it could be, but in C that would mean somebody would have to allocate it or pass an entire structure onto the stack, both which are bad approaches in software. So without even thinking about it, I created a output parameter that we just fill in this function, and it's up to the caller to figure out where this memory is coming from and where it's supposed to be written to. So the point is, these enums give us code duplication. You can see that very clearly here. The green and purple blocks are identical, and similarly the yellow and red blocks are identical, and similarly again the last 2 blocks are also identical. So there's a lot of code duplication going on here, and by just creating a switch case function that handles each orientation separately, you're essentially duplicating a lot of code. And you'll find that almost inevitably whenever you use an enum. There's nothing wrong with using them from a readability point of view, but you do duplicate code, which does matter if code size is a problem. It also matters for performance, as you'll see in a second. So it's possible to change this a bit around. We see that there's a bunch of places that are duplicated, so we can basically just turn it around and say that we write the code once and we give the conditions that reach this code once, and we can basically turn this into 3 if blocks that fill out a third of the output structure each, and that works just fine. But you now have to do 2 checks in each if statement, because there's 2 conditions that reach the same code every time. So thinking about it a bit more clever, we can actually do something else. So my mental engineering way of thinking about it is that these orientation actually define operations. The three operations that I have as a building block is the flip origin to the other edge of the x-axis, the flip origin to the other edge of the y-axis. You can see those happening here in the portrait. You flip it to the other end of the x-axis, and in the landscape you flip it to the other end of the y-axis. Other way around, sorry. And finally you have a way of swapping the x and y dimensions before you do this flipping. You can actually build some bitmask enums with this in mind, and they look something like this. So I define my bitwise operations and just give them a bit each, and it doesn't really matter which bit is which. Then I define my operations as basically, well, I define my orientations as sequences of bits that need to trigger in order to achieve this. So here's the portrait mode, which has nothing happening really. So it's just nothing, zero. Upside down is basically rotating the grid 180 degrees. You can achieve that by flipping the x and y axis, and you are basically done. That pushes the red dot over there, and you can see over there, and you can see how that actually gives you the dot on the other edge of the screen if you just rotate it around. Whereas landscape left is flipping the bit over to that axis, and that then corresponds to this display if you rotate your phone around. And similarly, landscape right is flipping the dot over to this edge and rotating the phone around. And rotating the phone around is basically the bit swap. So, these are my operations, and I can now write my function like this, because as it turns out, these conditions here now have a bit in common all the time, a unique bit in common. So if I'm swapping the x and y axis, then I'm swapping the x and y axis in the transformed width and height. So that's the only bit that actually affects that. If I'm flipping the x, then I'm just setting that the origin x is in the other end of the screen, and same with the flipping of the y, other end of the screen. In result, I then end up with a bunch of assembly instructions. The switch and enum version of my code had 31 instructions, whereof 9 will be run off any given input, so that's actually pretty fast. But there's 4 branches in there, and branches can be a problem because you're basically fooling the branch predictor in the CPU, so maybe it works out, maybe it doesn't. The if enum version that I showed you next has no branches, and that's really good, but it has 19 instructions where all will be run, so it's far worse than this above maybe. The bitmask version is 13 instructions, significantly cutting down the number of instructions, and all of those instructions will be run. No branches again, and none of the versions did any memory operations apart from the store at the end, which is the same for all of them, so I'm not even counting it. Which is best? That's indeed the question. That all depends on what you're trying to achieve. Personally, I feel that this is cleaner because you only do one thing and there's no duplication of code, but it takes a while to get used to. I would be very pleased if I convince some of you to get used to this style of coding, but it's fine if you don't. The enum version that you showed at the beginning here is perfectly acceptable. There's nothing wrong with the enum version. It's fast enough, and that's good. So just keep it in mind that you always have options to reduce the instructions, reduce the overhead, and reduce the memory traffic if you need to be. The question is whether, of course, you need to, and honestly, in this case, you probably don't. As a result, the driver code in Mali uses this switch case definition because that was easier for the engineer that wrote it to understand. Giving me a little bit of heartache because I feel that this is not optimal, but it's good enough. This isn't performance critical code and nobody therefore actually cares. With that, I'm gonna end this example. So with that, I kind of want you all to, when you do low-level programming, have the constraints in mind. You don't really have to act on them, but it's something that should be lying there underneath the hood of everything you do and asking yourself, would this fit the platform I'm coding to? As long as you do that, you are doing low-level programming. It doesn't really matter if you're writing that in JavaScript. By the way, you can actually write pretty fast JavaScript if you really want to. I'm not recommending it to anyone because JavaScript is still a horrible language, but you can. So with that, thanks for me. I hope this was at least somewhat informative, and if not, oh well. Good luck with the class.